In this chapter, we're going to be discussing the concept of generic programming. Generic programming allows us to define classes and methods and defer specifying a data type until defining runtime code that uses the class or method in question. The reason we want to do that is to make our classes and methods more flexible so that they can handle multiple data types. A simple example will help explain this concept, and we'll be defining that example in the next two lessons. So let's get started. We're going to create a list class, and this list class will allow us to create a list of items. It could be a list of items we need from the grocery store. It could be a list of phone numbers. It could be a list of grades. It could be a list of the amounts we spent at the grocery store. It could be lists of anything. And because of that, we don't want to tie ourselves down to a specific data type when we create the data structure that stores the items in the list. So the way we get around that is by using generic programming. The way generic programming works is in the definition of a class, we specify a type placeholder. And we do that by writing less than sign and then a letter or variable. It doesn't have to be just a letter, followed by a greater than sign. This letter, the letter T in this example, is a placeholder where the data type will be provided later on when we write code that uses the list class. But when we're just defining the list, we defer specifying a data type by using the type placeholder. So to continue on with the definition, we need to create an array field to store the elements of the list. And here's where we use type placeholder. So our field is called data store, and we know it's going to be an array because we put open and close brackets right here. But we're not specifying the data type by putting a placeholder value in instead. We also need a field to store the size of the array, and we need a field to store the current position inside the array as we add or remove elements from the array and from the list. So those will be our fields. Now let's define at least just the constructor. And in fact, that's how we'll finish this lesson, by defining the constructor. And then we'll go back in the next lesson and flesh out the definition a little bit more and test the class. The constructor has to do a couple of things. First of all, we have to decide the size of the list, so we're going to pass that in when we instantiate a new list object. We'll set the current position to 0, and then finally, and most importantly, we have to initialize data store, our array. And that involves a little trick. So what we have to do is we have to create a new object array and then cast it to the data type that's going to be provided when we instantiate a list in user code. But for now, we use T as a placeholder for the type that's going to be defined later. So I know that looks a little odd, but it's the only way we can correctly initialize the data store field. And that's all our constructor has to do, so we'll finish that up, and then we'll finish up our class definition for now. So let's compile it very quickly to make sure that it works. And understand that there's going to be a couple of notes that we're using an unchecked code, and we can't really change anything about that. So let's give it a try here. So there's our note that we're using an unchecked or unsafe operation. Understand that in real life, we would not create a class of this type because there are much better list-type classes defined in the Java libraries. This is only to demonstrate how generic programming works. So with that, we're going to wrap up this first lesson, and we'll move to the next lesson where we're going to continue the definition of our list class.